Hi everybody, we're back with a little more intro trigonometry. Okay, so we've discussed how you measure angles on the coordinate plane in degrees, but it turns out that we don't use degrees in trigonometry, and you actually don't use degrees much in advanced math beyond trigonometry. So we're going to talk about a new measure of a new angle measurement unit. And that new angle measurement unit is called, turn my pen back on here. That new angle measurement is called a radian. Let's define what a radian is. Here's the picture of a circle. This is the center of the circle right here. So this is a central angle. You probably learned that in geometry. A central angle is an angle that has its vertex on the center of the circle. And we're going to label this circle, or label this angle with our unknown angle symbol, which is theta. The Greek letter theta that we commonly use for angles. And let's label a couple more things. Let's label this r. You should know what that is. The line that goes from the center out to the circle. Yep, that's the radius of the circle. And we're going to call this distance right here S. Now what I'm calling S there is the length of this arc. The length of that arc that I'm showing in blue here. That is the length of this arc right here. So it's the arc that's intercepted by that angle. Okay? That's S, the length of that particular arc. A radian of measurement, a radian of angle measurement, is the angle that we need in order for that arc that we intercept to be exactly the same as the radius. So when these two lengths are the same, this angle that we have to move in order to get those two the same is a radian of measurement. That's the definition of what a radian is. So again, a radian is the measure of a central angle that intercepts an arc that has the same length as the radius. That would be the definition in words. One more time. A radian of measurement is the measure of a central angle that intercepts an arc that has the same length as the radius. We can set up a formula for this, and it says the following. An angle measurement, and we're talking about in radians now, can be defined how many radians we have as the length of the arc divided by the radius. That's our formula for determining the size of an angle in radians. Okay? So I hope you can see that if S and R are the same as they are in this, as I've discussed right here, if S and R are equal to each other, we have a fraction that's equal to 1. So we have 1 radian of angle measurement, 1 radian. Now there is a symbol, there is an abbreviation for radians, RAD. And you could, if you wanted to, write 1 RAD. But it turns out that since this angle measurement is actually the ratio of two lengths, say if they're both inches or both feet or both centimeters, that actually this turns out to be a unitless measurement. So typically when you see radian measurements in trigonometry or advanced math, there are no units next to them. So if I were to say an angle has a measurement of 3, you can assume from here on in that that's 3 radians. If I mean angles, I would write, if I meant degrees, I would write 3 degrees. I would use the degree symbol. So if you see an angle measurement without a degree symbol, you can assume that we're talking about radians. Okay? So let's get a little more specific with radians. Let's talk about a full circle. One time completely around the circle. Let's do our formula again. So theta equals the length of the arc. Well, what's the length of an arc all the way once around a circle? It's the circumference of the circle. The arc measurement going all the way around the circle. The length of this line going all the way around the circle is the circumference of the circle, isn't it? And if you know your formula for circumference for a circle, you know that it's either pi times the diameter or 2 pi times the radius. The circumference of a circle is pi times the diameter, or since the diameter is 2 times the radius, 2 pi r. And hopefully you learned that in geometry. Okay? We're going to divide that by r. That's what our formula tells me to do. But look what happens. The r's cancel out, top and bottom. So what have we just found out? We found out that for a full circle, once completely around the circle, that is 2 pi radians. I'll put the radians in here, but I'll put it in parentheses because we normally don't write it there. But a full circle is 2 pi radians, according to our formula. Okay? Which leads us to our final discussion in terms of, our final discussion is how to convert degrees to radians and radians to degrees. Okay? Let me go ahead and clear everything out here so I've got a clear slate to work with. There we go. So, we just learned that, and let me write it here, that a full circle is 2 pi radians. But we also know that a full circle is 360 degrees. Okay? So 2 pi radians equals 360 degrees. Or you could say that pi radians is how much if you divide both sides by 2? 180 degrees. Okay? So let's say I had an angle measurement of 90 degrees. I could multiply by a conversion factor that changes degrees to radians. Well, I know 180 degrees equals pi radians. And I'm putting degrees on the bottom so that that unit will cancel out. I hope you can see the degrees will cancel top and bottom there. What do I end up with? I end up with 90 pi over 180, and when I reduce, 90 goes into 180 2 times. So a 90 degree angle is pi over 2, and that should make sense. If I cut that 180 in half, I have to cut the pi in half too, don't I? Right? Let's do one that isn't so standard. How about, 36 degrees. So again, I'm going to multiply by pi over 180 degrees. That's going to be my standard way of doing these. And I'm going to get 36 pi over 180. Well, it turns out 36 goes into 180 evenly, goes in 5 times. So that is pi over 5 radians. Now, what if I wanted to go from radians back to degrees? Well, I hope you could see that if I have to multiply my degrees by pi over 180, then I have to multiply my radians by 180 over pi to go to degrees. I'll give you a way of remembering that in just a second. So what if I said, let's see, what if I had 3 pi over 2 radians, and I wanted to know how many degrees that was? Well, I can multiply by 180 over pi, right? Let me do a little trick here. 2 goes into 180 90 times, doesn't it? Okay, and what else? The pi's cancel too, don't they? I get 270 degrees. Now, if you wanted to multiply 3 times 180 and then divide by 2 to get the 270, that's okay too. There actually should be a degree sign right here. Okay? So, bottom line then is to go from, let me clear out some stuff here, to go from radians to degrees, you multiply by 180 over pi. To go from degrees to radians, you're going to multiply by pi over 180 degrees. The way to remember this, or at least the way I choose to remember it, is that in most cases, radian measurements have pi in them. Degrees don't. So if I'm going to multiply by something, say I have degrees, and I want the pi to show up in my final answer because most angle measurements in radians have pi, I'm going to want that pi on the top so it shows up, right? But if I have an angle measurement in radians, which typically has pi in it, and I want that pi to disappear, if it can, to give me a degree measurement, because most degree measurements don't have pi in them. I want the pi in the bottom so that it will cancel out with the pi in the radians. Make sense? I hope so. Okay, that's what a radian is. See ya.